use it to approximate the square root of 1.02. This is no calculator. So here's where this kind of came about. That if I wanted to find the value of the square root of 1.0, I'm giving you a very, very simple one. We know the square root of 1.02 is approximately close to 1, right? The square root of 1 is 1. I'm giving you a very easy example here. Just kind of simplify the thought process. But if I had the square root of 15.974, how would you know that without a calculator?
It's close to 5.
It's pretty close to 4. Yeah.
But think about it, the bigger I get, if I gave you the square root of 110.594. See how I'm getting further and further away?
Between 10 and 11.
Somewhere between 10 and 11, but where, right? That's where we're getting a little more, we're getting pretty far off.
Yeah, it's close enough.
Okay. Not close enough. That's not close enough. Okay. So, this is the idea. If I want to find this value, I'm going to use a linearization at 0. Kind of telling you where. You have to be told where we're doing the linearization. Because think about it. This looks, will you tell me, what does this look like?
Yeah, shifted to the left.
Shifted to the left. Does everyone agree with that?
Yeah.
So if I find a linearization here, that line's completely different than finding a linearization here, correct? So you have to be told where. So all I'm going to do is find a tangent line here. That's the first thing it says. When you're asked to find a linearization, you're finding a tangent line. So in order to do that, let's first find the point. That is the point 0, comma 1. Plug it in, right? I've got my x and y. Now to use the tangent line, what else do I need? I need the derivative, the slope, correct? So, f prime, well, let's go ahead and write that first. 1 plus x to the 1/2. So, u is 1 plus x. F of u is u to the 1/2. So, I have 1/2 u to the negative 1/2 times 1. So, my derivative is 1 over 2 square root of 1 plus x. That's the derivative anywhere, but I want the derivative at 0. What will that give me? 1/2. So now I have a slope and I have a point. Let's find a line. So y minus 1 equals 1/2 x minus 0. So I have y equals 1/2 x plus 1. And this is where we usually just call it L of x. This is my linear approximation. I replace my y with L. Really is the exact same thing, but I'm now saying it's a function of x. So this is the first part of the question. Now a lot of people in homework or handouts try to do 2 steps regardless of what the question is asking. This is a 2-step problem. But if I just asked you to find a linearization, done. We have found a linearization. We have found a tangent line approximation to that curve. Yeah? But now it's asking me in the second part, I want to use it to find what this is. This is where it takes some thinking. Compare these two. In order to get 1.02 on the inside, what did x have to be? 0.02. Does everyone agree that was 0.02? So what I'm going to do is I'm going to plug in 0.02 into my linearization. I'm saying, hey, it's close enough. To do that, I'm going to make that be a decimal because that's a whole lot easier. Right? And remember when you multiply that, watch your decimal places. That'll give you 10, but you want 1, 2, 3. 1, 2, 3. 0.01. 1.01. So without a calculator, without actually taking a square root, I'm saying the square root of 1.02 is about 1.01 using my line, not the curve. Can you understand what's going on there?
Yeah.
A lot of people feel they need to plug in something, but if you're not asked to use your approximation, you're not plugging in anything. And this, your x is different. A lot of people want to try try to plug in, go back up, plug in 0 for their line, which might be the case depending on the function. We have to kind of compare them and what would x have to be. Try another. See how far you get.